So, by the end of this video, you'll have your very own private and secure self-hosted remote access back to all of your devices and services on your home, office, or even your friends and family's networks. This is currently my preferred setup using Tailscale along with a self-hosted Headscale Docker container accessible by fly.io tunnel. If you don't know what any of that means, I'll run through it all now. Or if you want to skip directly to the install process, I've included the time codes below. In the past, I've tried using different ways of accessing my computer remotely, such as opening a remote desktop to a port to the public, which is totally insecure and you shouldn't do it. I previously accessed my personal Nextcloud and Home Assistant instance remotely using a Cloudflare tunnel. This is better, but still has issues with being publicly available online unless you enable access control. And also Cloudflare can see anything that is sent and received via their tunnels. And when Home Assistant announced that they'd patched a critical security bug that allowed anyone to remotely control backups and plugins without being logged in, this made me think twice about exposing my home lab to the public internet. That's where Tailscale steps in. You might have heard of it. It's currently quite popular in the home lab community. If you've not come across it before, you can think of it as a secure mesh VPN network where each of your devices has direct access to any other device which has the Tailscale client installed. It works by setting up a direct connection between each of the Tailscale clients using a protocol called WireGuard. It works even if they're behind firewalls. It uses a technique called network hole punching. This makes it much faster than a typical VPN, and by default using split DNS to only direct traffic to your local network if it matches one of the clients, so that all of your internet traffic doesn't go through the VPN unless you specifically choose it as an exit node. I've included links below to their full documentation that explains in more detail how this actually works. Their free tier is very generous, allowing up to 3 users and 100 devices all to be connected. This may be fine for most people, however, I'm not most people, and I've spotted some downsides. While Tailscale Client is open source, the coordination server is not, and it's the coordination server that allowed devices to join your network. So, for example, in the unlikely case of a security incident, another user could join your network without your knowledge or permission. Also, pricing could change and any service downtime could lock you out of your network. So thankfully, this is where Headscale steps in. Headscale is an open source implementation of the Tailscale coordination server based on the documentation and client code that Tailscale have kindly made open source. While Headscale being open source doesn't necessarily mean that it will be securer than Tailscale's coordinator, it does mean that we will be less of a target since we can self-host it. If you're like me, your home internet provider might not issue you with a public-facing IP address, since they're becoming scarcer and more expensive. So instead, they might be using a double NAT connection. So to get around this firewall and network issue, I'll be using a Fly.io tunnel. Now I've tried using a Cloudflare tunnel in the past. However, this uses post-based WebSocket connections, which at the time of recording isn't supported by Cloudflare tunnels. Now you could use Fly.io to run the Headscale server in the cloud. However, I prefer to run it locally in my home lab. And another advantage with Fly.io tunnel is that our home lab server will be requesting the HTTPS certificate and hosting the secure connection, so that the connection to our Headscale server will be fully end-to-end encrypted, meaning that Fly.io and anyone else along the connection won't be able to view our network traffic like a Cloudflare tunnel can. If you do have a public IP address, you could skip the upcoming parts where I reference Fly.io, or follow along with me using Fly.io until you have a working setup, and then later removing it and expose the Headscale port via your firewall or router. Okay, so let's jump in and see how we can deploy this on our very own network. First, let's head over to Fly.io and register for a new account for our tunnel. Their free allowance is quite generous, but they do require you to enter your credit card details before allowing us to deploy. This helps them to prevent people from abusing their services. We can use an online card, such as one from privacy.com in the US and Revolut's in some parts of Europe, that will allow us to avoid accidentally exceeding their free allowances, which we won't be exceeding for this project, but be sure to double check their current free allowances, as they may have changed since this video was published. Now that we've got a Fly.io account, we're going to need somewhere to host the Headscale coordination server in our own home lab. This could be as simple as a Raspberry Pi, if you can actually find one, an old laptop, a Proxmox server, or even in the cloud. I'm going to be installing on my home lab Proxmox server using a Ubuntu server and Docker. I previously have created a Ubuntu server template, so I can right click and clone this. I'm going to call it Headtail Scale, and I'm going to make a full clone. Once that has been created, I can click on it and click on Start. All of the code examples I'm going to show are linked down in the description below, so you don't need to try and copy them from this video. You can copy them from my GitHub page. Now let's SSH to the server and make sure that it's up to date by using sudo apt update and sudo apt upgrade. Looks like everything is up to date, so let's install the Fly.io command line tools. This will install curl and instruct curl to download and install the Fly.io command line tools. Let's add the export commands that it's output here to our bash rc so that Fly is available when we log into our server. We can select these, and I'm going to use nano to edit our bash C file. And I'm just going to go to the bottom by brushing the page down and paste. And then I'm going to exit with Control X and Y to save. In order to make this active, we also need to source the file, which we've edited, which is bash rc, so that we get those export commands. Now let's create a fly tunnel folder and create a new file inside called fly toml with the following contents. So here we will need to choose a new random app name that we will be using as our Fly.io subdomain. You can change this to whatever you like, as I'm going to delete this example afterwards. So by the time you're watching this video, this subdomain won't belong to me anymore. Make sure that this domain subdomain is set in both the domain in the environment here and the app just up here at the top. The Docker container that we're using in the build image is one that I've created over on GitHub. It forwards local Docker ports to a remote Docker instance. We'll be using this later to expose our Headscale's coordination server. We've set up one peer to expose the Headscale service via port 80 for Let's Encrypt to issue a HTTPS certificate, and port 443 for HTTPS once Let's Encrypt has set it up. We have persistent storage called WireGuard data, which we'll be using to store our config. We expose UDP port 51820 to allow WireGuard connections, and we have the regular port 80 and 443 exposed as well. Let's save that with Control X and Y to save. Now let's deploy it via fly auth login and fly launch. The first time you run this command, it's going to ask you to copy a URL and then log in. So I'm going to copy this and I'm going to paste it into my browser. And then we can continue with my new account, and we can now close this tab. So the following options, we're going to say yes to copy the configuration. We're going to leave it as the name that we've chosen. In this example, I've chosen Bond Street 0007. We're going to choose the location closest to us. In this case, it's London. We don't need a Postgres database, so we're going to say no to that. And we don't need Redis either. And we can say yes to deploy now. And we also need a dedicated IP address for this instance, so we're going to say yes to that, and after a few minutes we should have our very own Fly.io tunnel. Now that it's started, a peer1 config file will be automatically generated on the Fly.io instance in the etc WireGuard directory. We're going to need to be able to access that, so we can use the command fly ssh console to log into the server remotely, and we're going to output the contents of etc WireGuard peer1 config. We need to copy the config And we also then need to remove the file, as we no longer need this file on the server anymore. We can disconnect with Control D. Now we'll create a new folder called Headscale WireGuard via make directory and copy the peer1 config to the new file called wg0.conf. Paste that in and use Control XY to save. Now that our Fly.io server is ready, we can install Docker Community Edition via their install script, which uses curl to get their install script and then execute it via bash. We'll also need to make sure that my local user has access to use Docker via sudo usermod -a capital G Docker user. And if I log out and log back into the server, I should be able to do Docker PS, which should show that there is nothing running. Next, in the Headscale folder, we need to create a config folder and download the sample config from the Headscale GitHub repo and make a few tweaks. Now we need to set the server URL to match our Fly.io subdomain and listen to port 443. So I'm going to comment out the server URL and paste in my server URL, which I've created over on Fly.io. We also need to update the listen address from port 8080 to port 443, and the 0000 allows it to listen to all incoming connections rather than just local connections. We're going to search via Control W for email, and we need to replace this with our own email address for the Let's Encrypt certificate. So going to update the hostname to match the hostname that I've set up in Fly.io, and we can save via Control XY, enter. Next, we're going to use the following Docker Compose file. Again, this can be copied from my GitHub page, so you don't have to try and copy from my screen. So I'm going to use nano to create a Docker Compose.yaml, and I'm going to paste in the following. Here, we're using two services. The first is Headscale, which is set to run the serve command, and will also restart unless it is stopped. And we've also added our config folder as a shared volume. Below the Headscale service, we have a WireGuard peer, which we'll be using to connect to Fly.io. We can then save this again with Control X and yes. Now that we have everything in place, let's start it up via Docker Compose up-d. And we can check that it's running via Docker Compose logs-f for follow. So by the looks of it, it has started up. So to check that our service is actually running, we can also go to the URL which we created. We can see in our dashboard that it has successfully created those services. And if I go to a new tab and go to the URL and add /swagger, then hopefully I should be able to see my new Headscale service. This shows the Headscale API documentation. Great, now that our server is up and running, we can start adding our computers and laptops and even phones to it. First off, let's cancel out of this by Control C, and we'll add a new user called digital user via docker exe headscale. The second headscale is to run the headscale command inside of the headscale docker image. Users create and then digital user, and we can see that we've added a new user. And now let's try and add an Android phone to the network. First, download the Headscale app from either the App Store or F-Droid Store. I've already pre-installed this to save time, so if I click on that, I'm going to allow notifications, and we're going to click on Get Started. The first thing you'll notice is we have a Sign In button, and if we were to click that, it's going to try and log us in to the Headscale service, which is not what we want. So we need to cancel that, and instead we need to click on the hamburger menu a couple of times until it shows us a change server option, which we can then click on. So here we can copy and paste the URL which I previously set up. So this is going to be the Fly.io subdomain that we've set up. So that's going to be bond-street/007.fly.dev, and we're going to click on save. Now we should be able to sign in. Here, this gives us the command that we need to run on our Headscale server in order to allow our device to connect. So we need to tap and hold to copy it and select it, and then I'm going to share it via KDE Connect to copy it to my computer. Then if I go back over to my terminal, I can then paste this in. We will need to change this slightly to match our server, so we need to run the docker exe headscale command. So if I copy that one and paste it before the headscale so that it matches up like that, and we also need to update the username to match the user that we've just created here. So pressing enter now, it should say that the machine is registered. If you're using iOS, once Headscale is installed from the App Store, there will be a new set of options in the Settings app. I've linked instructions down below in the description. Now to check to see if it's connected, we can also run docker exe Headscale nodes list to check that our device has been successfully added to our network. Now that we've successfully paired our phone, we'll see that the network list is pretty much empty. So let's add our Ubuntu server to it as well. We need to create a new pre-auth key for our Tailscale Docker container by running the following command. So here we're adding our user and pre-auth keys, and we've set it to expire in 1 hour. So now we need to copy this key, and we'll create a new Tailscale folder and Docker Compose file by running make directory Tailscale in our home directory and then changing directory to it and editing docker compose.yaml. So let's paste in the following code from my GitHub page. So this Docker Compose file will be running Tailscale from the Tailscale stable repo, and we'll be setting a host name of head Tailscale to match up with the service name. And here you see that I've got commented out the Tailscale auth key, which I need to paste in here. So let me paste that in here. In the Tailscale extra args, we need to update the fly dev URL to match our head-tail coordination server, and also update your local IP address if you want to allow your device's access to your local network. Let's save this by Control X and yes again, and start up the client via Docker Compose up. And it looks like we've successfully connected OK. In the Docker Compose YAML file, you may have noticed that I added an advertise routes option. This allows any client that is connected to our network to access any of the routes that are exposed via that Tailscale server. We can see here that it is advertising those routes, but they have not been approved. So let's approve those routes now via Docker Headscale routes enable and then route 1. And also run that again with route 2. Now we should see that those routes have been approved. We also need to approve the third one. I would recommend updating your router to use a different 192.168 address for each network you add. Otherwise, there is a setting in the desktop and mobile apps to allow local access if you connect two networks with the same IP address subnet range. In this container, I've also allowed it to be used as an exit node, which means that we can redirect traffic through my home network. So let me switch back to my mobile. It is now connected. And we can see that we have our Head-Tail-Scale service successfully running. Now let's throw a Windows machine into the mix and see how that is handled. I've created a new Windows VM, which I'll switch to now. And now we need to install the app. So either we can do this by going to the websites. I prefer to use the Windows terminal and then use winget to install the app. So you can do this via winget and then search for Tailscale. And then yeah, we can use the ID to install. So we can copy that and do winget install Tailscale. Similar to the Android app, when we click on Sign In, we're presented with the Tailscale login. So to use our own Tailscale server, we first need to change a few registry settings. To do this, we right-click the Windows terminal and click on Run as Administrator. And we need to paste in the following commands. I'm going to accept anyway. So this will then set our login URL to be our very own Headscale server. Once we've set these registry keys, we'll need to restart our computer for them to take effect. Now when we click on sign in, we should be presented with the Headscale registration code, which I can then copy and paste back onto the server. Again, here we need to update the username to be digital user, and also add docker exe C Headscale, and then Headscale to run the command, and now it's successfully registered. So now if we list, we should see that the two devices are on and my phone is currently off. We should now see that the Tail Headscale server and Android phone are able to connect to each other no matter which network we are on. If you're running this on macOS, I've linked a guide on how to change the coordination URL in the guide down in the description below. Each client by default is assigned a static internal IP address. So if you have your own custom domain, you can create a subdomain on it or a wildcard so you don't need to remember the IP address. Since I'm using a static IP address 192.168.5 assigned by my router, and I'm exposing this via the advertise routes options, this means that I can use this IP address both internally on my network and remotely when Tailscale is connected. Here you can see that I've added a wildcard subdomain, star.pve, and that points to my Proxmox instance. So by using this wildcard subdomain, we can run services such as Home Assistant, Nextcloud, or even Jellyfin or Plex without having to create a new entry for every single service. And what's more, we can use a separate service like Traffic or Nginx Proxy Manager to generate a TLS or HTTPS certificate using a DNS challenge. I've linked a separate video from the excellent Christian Lemper who goes through this process in more detail. I hope you found this video useful, and if you did, feel free to buy me a coffee over on Patreon, and don't forget to subscribe and click the bell to get notified whenever I release a new video. Thanks for watching and have a great day.